In this video, I will demonstrate how to set up the study architecture for my analysis using the Study Examples and Outcomes module of Compass. Compass runs on a server and I access it through a browser. In the prior demo video, I showed how to create a project and upload and organize the mass spec files to be analyzed in that project. We are now ready to structure our first analysis. Outside this video, you can access support through the internal help bubbles while using the software at any time. Hover over or click on the help bubble for tips and information. In this project, I am working with a set of 729 mass spec files, each of which is a replicate proteomics sample of one of the NCI 60 panel of cancer cell lines. There are 12 or more replicates for each cell line in the NCI 60 panel, allowing comparison of individual cell lines or groups of cell lines across the panel. This data set is from a published study, and the raw mass spec data is available in the PRIDE Proteomics repository. Importantly, Compass can be used for any comparative analysis involving groups of examples being compared to each other. While this is a proteomics study, Compass can also be used for metabolomics, lipidomics, or other applications. Whatever the application, Compass is designed to work for studies comparing large numbers of individual examples. A study the size of this example, comprising 729 mass spec files, is routine. There are several parameters the user can define to set the analysis architecture. All involve drop-down menus that are pointed back at specific columns within the assembly file, which file was built and uploaded in the prior step. Data selections options allow the user to define categories within the examples that can be included or dropped out of analysis, creating subcategories in the analysis. In this example, I can set subcategories based on information provided about each cell line. If I wanted to select cell lines derived from white female individuals, I would select race as a data selection and select the corresponding category. I could then set another data selection for sex and categories to be included or excluded from analysis there. Here, I will not include any data selections and will delete the two I've shown you. Next, I choose Outcome Selection, which identifies the categories that are the basis of comparison. In this example, I might choose to compare individual cell lines across the NCI 60 panel. However, this makes for many individual comparisons. All comparisons are binary. One category is compared to another. For 60 cell lines, this will be a minimum of 59 comparisons. If this was my goal, I might choose to do such an analysis in a smaller group of cell lines, using data selections to create subcategories. In this example, I will instead compare the data across the organ category. If I click Edit Outcomes, I can see there are 9 different organ categories. Using Edit Outcomes, I can delete, combine, or create new categories that relate to the organ classification. Also, as part of outcome selection, I need to set the classifier style, which options define how the categories will be compared to each other. The options are fairly self-explanatory. Relative to first uses the first category listed as a reference sample for all of the others. If you want to change which category acts as the reference, you can just change the order in Edit Outcomes. The easiest way to do that is to create a new category whose name begins with the digit 1 and select the reference category within. You can now delete the duplicated category from the list. Relative to previous compares each category to the next in the list. This classifier style can be useful for time series. Each to others compares an individual category to the combined data across all the remaining categories. This method of comparison is particularly powerful but requires a high degree of sensitivity. All pairs compares every category to every other category. While this seems ideal, the number of comparisons can explode if the number of categories climbs. For the 9 categories here, all pairs would yield 36 independent comparisons. Finally, the Add Data from Assembly allows the user to select columns from the assembly file to be included as potential classification data. If there are assay scores or other information that you want to include as a parameter alongside the mass spec data, select that data here. Once the overall study architecture has been defined and submitted, Compass will report the number of examples that relate to the selections, list which columns will be included as data for analysis, if any, list the categories to be compared, and finally, list all comparisons that will be made. This module defines the overall design of subsequent analysis, and any changes made here will require that subsequent modules be rerun. Up next, I will demonstrate how to use the Parse Example Subset module, which will identify the subset of files and the data resolution for initial analysis.